everyone, welcome back to Kidding Around. My name is Melanie Smith, and I think it is totally terrific that you are here with me today for another Test Tube Tuesday. As you know, on Test Tube Tuesdays, we do all things scientific, and of course, today is no different. Today, we will be talking about the concept of density. Before we do that, though, if you like what you're seeing here and want to follow along with all of Kidding Around's videos, please make sure to subscribe to our YouTube channel. Below each video, click the thumbs up, and also follow us on Facebook, Instagram, and Pinterest as well. Thank you very much. All right, so let's move on to our topic, the topic of density. Have you heard that word before? Well, let me see if I can paint an illustration in your mind before we talk about it a little bit more in depth. I want you to imagine that you have a container that has a pound of feathers and a container that has a pound of gold in it. You are going to climb to the top of a very tall ladder, of course very carefully, and you are going to drop those two containers at the same time. Which one do you think will hit the ground first? I hope you caught that I said you had a pound of each material. So a pound of feathers and a pound of gold, and because of that, they would probably hit very close together if you dropped them at the same time. So you drop them from up here, they weigh the same, they go down and they hit the ground at the same time. Of course, if you had a pound of feathers, you would have a great big container that you would have to hold that contains a pound of feathers, right? Because feathers are very light on their own. So you'd need a lot of feathers in that container. If you had a container of gold, it would be much smaller than the container of feathers because gold is much heavier per piece, right? So now I want you to imagine that you have two containers that are exactly the same size, and you stuff one full of feathers and you stuff one full of gold. They're the same size box for each material. Now you climb to the top of that very tall ladder very carefully and you drop them. Now what's going to happen? So you have your box of gold and your box of feathers. They're the same size. That gold is going to fall much faster than the feathers, right? There is the concept of density. So if you had the same volume of feathers as you did gold, meaning that they fit in the same space, that same size and shaped box, the feathers fall slower. The gold falls faster. So here is where the concept of density lies. Density is the mass of an object divided by its volume. So let's break that down just a little bit. Volume is the amount of space that something takes up. So if you've been given a present in a box, you could find the box's volume by measuring its length, its width, and its height. Then you would multiply the length by the width, and then multiply that figure by the height. This would give you the box's volume. The other term that we talked about as we were defining the density equation was mass. So mass is a bit harder to describe than volume, but we are going to use mass as how heavy something is. For simple density experiments, you can use that. That's not completely correct, and you will learn about the difference between mass and the weight of something as you go on with science. Basically, the difference is that weight is a force which is affected by gravity. So an object would weigh less on the moon than on the Earth because there is less gravity. But mass stays the same wherever you are, if you're on the Earth or on the moon or floating in outer space. But like I said, for simple density experiments like we're doing here, we are going to use mass as the heaviness of an object. So once we know an object's volume and an object's mass, we can figure out its density. This is done by dividing the object's mass by its volume. So the formula for density is density equals mass divided by volume. But even said more simply and easily, basically, density is how compact an object is. So think back to our feather and gold experiment. If we have 1 pound, they fall together. If we have the same size box, the gold falls faster than the feathers. If you think that through, you're starting to understand density. The gold is more compact and therefore more dense than these feathers. We are going to do a fun experiment today that helps us understand the densities of two common liquids, the density of water and the density of vegetable oil. So to do this experiment, you will need a few supplies. You will need a cookie sheet or a baking tray with the sides raised. This is just in case we spill. We're hopeful that we don't, but with this experiment, it's almost inevitable, so it's very good to be prepared. You will also need 2 glasses that are the same shape and size. They can be plastic like these, or they can be glass. The important part is that they're clear and that they're the same shape and size. And then you will also need some cardboard. This is from a wheat thin box. A cereal box works well as well. And you'll need a pair of scissors to make sure that you can cut this box to the right size. And then obviously you will need some water and some vegetable oil. So let's get started. The first thing that I am going to do is lay my cardboard box on top of my cup and cut a piece that ensures that the entire mouth will be covered by this cardboard. All right, so once I have that looks pretty good. I am going to remove the cardboard and then I am going to fill this glass to the top, or as closely to the top as I can, with vegetable oil. So I'm going to very carefully see if I can get right to that rim without going over. Just a little bit more. There we go. I thought I was going to go over there for a minute, but I didn't. All right, and then I'm going to take my other cup and I am going to fill it with water in the same way. So I'm going to try to fill it clear to the top without going over. I went over just a little bit, but you know what? I've got my tray here, so it didn't matter. All right, now this is a little bit tricky. I am going to put my cardboard on top of the glass of water and I'm going to make sure that the lid, or that my cardboard lid completely covers the mouth of the glass. And then I'm going to very carefully but quickly flip it over. A little bit of water may come out, that's okay. If you flip it over quickly, you'll be all right. All right, and then I'm going to hold it as flat as I can, because moving the cardboard actually makes water come out, as you saw there. So I'm going to hold it as flat as I can, just like I did there. And I am going to place my cardboard and my glass of water on top of the oil glass. I'm going to do my best to make sure that the mouth of this top cup meets up with the mouth of the bottom cup. Now this is where it will really help if you have 2 sets of hands. You're going to hold this water cup as best you can, and then you are going to slide out this cardboard piece. So you want the 2 cups to be touching after you've slid out this cardboard piece. So I'm going to do my best without a helper here. I think I can do it. And then we're going to watch what happens between the water and the oil. So once I get it set, there we go. And it happened pretty fast. Did you notice that the oil very quickly changed places with the water, right? I put the water cup on top, and now what's on top? The oil. Do you know why that happens? Because water is denser than oil. This is quite a fun experiment to do, if a little messy. Please do make sure that you have some parent supervision and permission before you do it, because oil can get very greasy. When you clean up the oil, which I know you will because you are great at cleaning up all of your activities, make sure to use some soap, because soap really gets in and cuts the grease that the oil leaves behind. All right, now let's move on to one other experiment that we are going to do, again relating to density. You know what, I think I'm going to go clean this up, and then I will meet you back here, and then we'll do our experiment, all right? All right, I am cleaned up and back. I am degreased. I used a bunch of soap to get rid of that oily residue, and we are moving on to our next experiment. So this one, just like our first one, is going to be a bit of a mystery until the end, and then we'll talk about it. So for this experiment, the supplies that you will need are a large plastic bottle with a lid. A 2-liter soda bottle works actually the best for this, but this oil bottle that I just used for our previous experiment I thought would work really well too. This is a great way to reduce, reuse, and recycle. So it needs to be large, like a 2-liter soda bottle or this one, but I'm sure as long as it's plastic and you have the lid, it will work well. You will also need a larger sized glass, and you'll need a pair of scissors. A straw with a bend is best. You'll need a small paper clip, some clay, just a little amount, or Play-doh, and then you will also need some heavy-duty aluminum foil. So I am going to be using the bottom of this aluminum foil pan. You could also use regular aluminum foil as long as it's the very heavy-duty kind. And then you will need some water too. So let's get started. We are going to make a little miniature diver. So to do that, I am going to cut his body out of foil. So I am going to cut a piece of this pan. I'm sorry, I know that's probably very loud on the video. All right. So I am going to cut a piece of this pan into a diver shape. Do you know what I mean by a diver, like an underwater diver? There is nothing perfect about this, but I am going to start at his feet and cut up, so that's his leg, and then I'm going to cut his arm and his shoulder, and then I'll cut his head or his helmet, and then I will do the same on the other side. We are symmetric, so I'll cut his arm, and then I will cut down his leg. So this is about the right size. He should be 1.5 to 2 inches tall. All right, now, as I mentioned, he's a diver, so we are going to make a tank for him to breathe from. You know, divers carry oxygen on their backs so that they can go very deep, and they carry their own oxygen so they can breathe. So to do that, we are going to take our bendy straw, and I'm going to cut it right about there. So the part that we want is this bend with the little extra pieces on it. I'm going to try to cut it so that it doesn't fly away from me. Here, I'm going to flip it this way. All right, there we go. See how they fly? But that's okay. I will clean that up later. The part that I want is this bendy part with the little pieces on it. And then I am going to take my paper clip. Now this is a little bit tricky. What I'm going to do is ultimately, I want the paper clip to be in the straw, keeping these two little pieces together. So I am going to unbend this first piece, like unbend to the first bend of my paper clip, and then I'm even going to unbend it a little bit further. And then I am going to insert it into the straw, just like that. And then I am going to try to bend it back. All right, this does not have to be perfect. This is just to kind of keep that same shape of the paper clip. All right, so that works pretty well. Then I am going to slide on this scuba tank as best I can onto the back of my diver. Now this takes a little bit of finagling and a little bit of squeezing the wire of the paper clip and squeezing the foil. That's all okay. What we really want is this straw to be connected, or not connected, but we want these two pieces of the straw to be very close to each other, and then on your diver's back. Of course, as you're putting this on, if you end up putting it on the front and you think that's the back, that's okay. You can just flip it over, and then your diver has the tank on its back. All right, you can see it is not perfect. It is not super easy, but it doesn't have to be pretty. We just want that straw attached on the back of our diver like a scuba tank would be attached. And I am really struggling here. let's see, I'm just going to move that wire, that paper clip around just a little bit till I have it the way I want it, and then I'll straighten out my foil. And there we go. So I have my diver, and then on his back, he has his scuba tank. All right, then I'm going to take a little piece of clay. Remember, I said it didn't need to be very much at all. And then I am going to put that clay on his feet. And there we go. We're just attaching it to the foil. You may need to wrap it around the foil a little bit, but just about like that. Once I have my diver complete, I'm going to give him a test dive. And so I am going to fill a glass with water, and then I will make sure that he floats. So here's my glass. That's enough water. And then I will put him in and see if he floats. And he does. As long as he stays at the top of the glass, he passed the float test, and you can move on with the experiment. If he doesn't float in your float test, maybe take apart the straw and the paper clip. It's likely that you have a hole in your straw, so replace the straw and try again. All right, well, my guy floated, so now I'm going to move on, and I am going to fill my bottle. Remember, this can be a 2-liter bottle or an oil bottle, like I'm using a big plastic bottle. I'm going to fill it almost all the way to the top with water. I have to say, you never realize how big these bottles are until you're filling them with water, and you realize how long it takes. I'm doing my best not to spill. I don't know, I may need my cookie sheet back here to catch the water. Of course, you can fill this in your kitchen sink or utility sink. A tall sink is the best for this, so that you can get the bottle under the faucet. All right, so I think that's about right. That's where I'm going to put my diver in. So I'm going to slide him in just like that. And then I am going to fill, the bottle up with water. You know, I actually need to catch that. I need just a little bit of air in the bottle. So I am going to just pour a little bit of that back. And then I am going to close my bottle, and I am going to squeeze it. And we are going to watch that diver dive to the bottom. Then when I let it go, the diver pops back up. And then I'll do it again. I squeeze the bottle, and the diver sinks. Do you see that? And he goes back up. We'll do it one more time. Squeeze the bottle, and the diver sinks, and the diver pops back up. I've been saying he, it could be a she. You know what? I want to do it one more time. We'll watch the diver sink, no matter if it's a he or a she, and pop back up. Isn't that fun? And you can do this over and over and over again. So the reason that this works is because of density. So when you put the diver into the bottle, the combined density of your diver and the straw and the paper clip and your clay was slightly less than the density of water. So it floated, right? But a small bubble of air got trapped in the straw when you put the diver in the bottle. So then when you squeezed the bottle, you increased the pressure of the water in the bottle. So the water was forced up into the straw, which compressed the air bubble in the straw. As the air bubble got smaller, the density of the diver increased, and the diver began to sink. When you released the bottle, the pressure lessened, and the water moved back out of the straw. So the air bubble in the straw returned to its original size, which caused the diver to become less dense and float back to the top of the bottle. Isn't that fun? And it's neat to be able to make your own toys with just simple household items, right? I would love to see pictures or videos of your density experiments that you do at home. Please ask an adult to take those videos and pictures and put those on our Facebook site. I'm so glad that you were able to join me today for our Test Tube Tuesday lesson. I look forward to seeing you on Thursday for our Thoughtful Thursday lesson, because I love spreading kindness around the world with you. Well, thank you so much for joining me. Thanks for kidding around with me. I will see you next time.